Welcome to today's deep dive. When you log into your bank account, you probably trust that your 256-bit encryption key is this impenetrable vault.
Right, yeah.
Like for decades, we've all just agreed that you either have the exact right key or you're locked out forever. But an April 2026 technical report on the Dillon-Collatz Framework just took a sledgehammer to that idea. So today's mission is unpacking this terrifying reality. 256-bit encryption isn't just vulnerable, it's, well, fundamentally broken.
Yeah, and the crack in the foundation didn't even start with cryptography. I mean, it started with a math puzzle from 1937 called the Collatz Conjecture.
Wait, the 3n plus 1 problem?
Exactly. Mathematicians spent nearly a century tracking the chaotic ascents and descents of these numbers. They treated them as raw, disconnected values. But then Timothy J. Dillon finally solved it by shifting the lens using curvature variable physics, or CVP. He proved these systems aren't just bouncing around randomly. They're caught in this physical tension between syntropy.
Syntropy, which is the structural force of order and healing, right?
Yeah. Right, syntropy, and then entropy, which is the force of chaos and fragmentation.
So trying to solve that puzzle with traditional math was basically like trying to escape a massive labyrinth by walking blindly through it, just, hitting dead end after dead end. But Dillon essentially levitated above the maze. By treating the numbers as a geometric structure, he exposed the underlying shape of the whole system.
Yeah, and applying that top-down geometric view to cryptography changes everything. The report demonstrates that SHA-256 encryption is not a random lock. It's actually a geometric map. And like any map, it has topography. Dillon's team ran simulations looking for what they call a rigidity leak.
A rigidity leak.
Yeah, which basically measures the roughness or structural distortion of the data's geometry. If a candidate key exceeds a roughness threshold of 1.618...
Oh, the golden ratio.
Exactly, the golden ratio. If it hits that, it hits a structural wall and is instantly discarded.
So instead of testing every single password combination one by one, they're measuring the physical shape of the data. The simulation instantly shrank this massively complex encrypted search space from, I think it was 132,303 candidates, down to 0.
Yeah, it didn't guess the password. It mathematically contracted the geometric space until only the exact correct solution remained.
Hold on, though. I have to push back here. If the cryptography protecting our entire digital infrastructure is basically an open door now, why hasn't your checking account been drained this morning? Why hasn't the global banking system completely collapsed?
Well, the threat is very real, but the defense has actually moved from software to hardware. Global systems are now deploying safety interlocks at the silicon level, specifically the NVIDIA IGX Thor Safety Island.
Oh, wow. So specialized hardware.
Right. Instead of relying on the broken math of encryption, this specialized hardware analyzes the geometry of incoming data packets. It detects those non-rigid malicious structures and physically rejects them in under 1.2 microseconds. That's before the main processor even has a chance to read them.
So the hardware is catching the geometric anomalies that the software can't. And because CVP maps any chaotic system, this geometry goes way beyond cybersecurity, because the report applies this exact same structural analysis to high finance.
Yeah, it takes level 2 micro movements in the stock market.
Those are the really granular second-by-second changes in the order book, right?
Exactly. It maps them into 4 deterministic behaviors. It completely abandons probability. By reading the structural reality of those trades, the framework can predict a slow bleed or a dead cat bounce without guessing.
It's tracking the predictable geometry of human panic and greed. And tracking human behavior geometrically is actually what led the creators to submit this architectural framework to Pope Leo XIV at the Vatican.
Right, yeah.
Which is the leap that really melts my brain. Taking a formula used to break encryption and predict stock markets and using it to quantify human morality. The framework mathematically models syntropy as the law of love, like grace acting as a binding, ordering force, and dispersion as structural evil and sin.
It treats human relationships as a physical geometric space. Just as the framework measures structural decay in a data packet or a market crash, it attempts to map how small acts of kindness or malice create cascading deterministic momentum across a population.
It's fascinating. The overarching realization from all these sources is that computational hardness, this comforting idea that some problems or systems are just too complex to solve and predict, is really just a geometric illusion. The walls of the vault were never there. We were just looking at them from the wrong angle.
Right. Once you map the underlying geometry, the complexity just collapses.
Which leaves you with a thought to mull over long after this deep dive ends. If every seemingly chaotic system in our universe, from 256-bit cryptography to market crashes, and even acts of human kindness has a predictable solvable geometry, does randomness actually exist? Or is chaos just an illusion created by our own limited perspective?